All right, so we're going to go back because I got cut off. It sounds as if we're going to have 3 videos. So hopefully you guys like my voice. So as I was saying, when you go to the doctor's office, you don't go in and get your height measured and then slant to the side to figure out how tall you are. That wouldn't make any sense. So in this case, when we're trying to figure out the width or the height, depending on what you're looking at it as, you want the straight up and down. And on the next slide, you're going to see why you can use this spot right here, this line, to figure out the width or the height, depending on what you call it. All right, let's go to the next slide. All right, so how can a parallelogram have the same formula as a rectangle or the square? You're probably wondering, how can 2 straight figures, rectangle, square, be the same as a parallelogram? Well, if you split this rectangle right down that up and down line, okay, and you have this triangle right here, if you take it and you slide it over here, wonder what shape it's going to be. Let's see. Slide it across, it becomes a rectangle. So really, a parallelogram, I'm going to move this, a parallelogram is just a tilted rectangle. Kind of interesting, huh? All right, so the next slide, let's see. All right, there we go. Here we go. So for this next slide, it's some example problems. So let's take a look. If you have a rectangle with a length of 9 and a height or a width, depending on what you call it, of 3, what are you going to do? Well, you're going to take the 9 times the 3, and you're going to get length times width, and the area is 9 times 3, which equals 27 centimeters squared. We add that 2 up here to show that we are finding area, and we see that this does have a unit. It's centimeters, so we have to label it centimeters squared. Over here, we have 3 numbers. We have a 6, a 2.5, and a 2. Remember, do you slant at the doctor's office or do you stand straight up? We stand straight up, so we're going to take the 6 times the 2 for the length times base times height or length times width, depending on what you want to call it. 6 times 2 equals 12 feet squared, and the unit here is feet. So we do feet squared. The last one, we know it's a square. For sure it's a square because it has 11 here and nowhere else. So that kind of represents to me that all sides are the same length. So we take 11 times 11, and you get 121 millimeters, since the unit is millimeters squared. That's how you would label it. All right, now let's look at the area or the formula for the area of a triangle, which is a little bit more work, which you guys got this, I know that. So this looks funny. You take 1/2 times the base times the height. So picture it as it's standing up. The base is right here. The height is the straight line that you can create, not the side length, because remember, you don't go to a doctor's office and stand at an angle. You go and you stand straight up and down. So you're going to take the base times the height. And honestly, guys, this is what I do. I don't do 1/2 times base times height. I take the base times the height, and then whatever that answer is, I divide it by 2. Because think about it. If I added another triangle right here, what would that turn into? It would turn into a square. So really, I'm just dividing my triangle, or my base times height, and I'm dividing it by 2. So let's take a look. That's not the height of the triangle. Just when I was getting a hang of this, you go and throw a fraction at me. For the love of pepperoni, why do we have to take 1/2 of the base times the height? Calm down and check this out. All right, so a triangle is really, I just said this, but a triangle is really 1/2 of a square, rectangle, or a parallelogram. I wish I could draw that for you guys on the whiteboard, but we'll do the best that we can. So if you look at this, you have a square, you split it like this, you have 2 triangles. You have a rectangle, you split it like this, 2 triangles. Parallelogram, you split it like this, 2 triangles. The real